So in tonight's video, we're going to move beyond just looking at single individual stars. We've looked at the different types of stars that exist. We've looked at how they're born and how they die, and now we're going to look at how they get grouped together in space. So stars don't just sit there all by themselves, right? They tend to actually come in groups. That's what we're going to take a look at tonight. So we're going to focus tonight on star systems. We'll get to galaxies in class tomorrow. So to start, right, a star system is a group of two or more stars. Right? So most stars in the universe are parts of star systems. Right? And we're going to look at a couple different types of star systems today. Our sun, though, is not part of a star system. Right? Our sun isn't with any other stars in space, so we're kind of the odd man out here. Right? There are planets around it, but the star is just there by itself. And so our first type of star system is a binary star system. Binary meaning two, right? Just like bicycle has two wheels. A binary star system has two stars in it, right? So they're double stars. The two stars kind of orbit each other, right? And we think actually that most of the stars in our galaxy are binary stars, right? So our sun, again, is kind of the odd star out. So these two stars formed together from the same nebula right near each other, and ever since they formed, they've just orbited each other. And we can detect a binary star system by observing their gravitational effects on each other. So as these two stars orbit each other, they cause each other to wobble. And so instead of staying in place, the stars wobble back and forth. And with a really powerful telescope and really accurate measurements over time, you can detect this wobble, right? So for example, this white dwarf J0923 has a binary companion, J3028. Right? This guy is too dim to be seen from Earth, but when we look at its companion star, we notice that over time the star would wobble back and forth, side to side, as this orbited it and caused the star to move. So let's think, how could we do something similar for planets around other stars? How would a planet affect a star? So, hopefully you thought about that for a second, and a planet would function in much the same way as an extra star would, right? A planet is also going to cause a star to wobble, right? So we discovered, as our telescopes have gotten better, that other stars had wobbles around them as well. And if a star wobbles with no other star around it, because we can't see the other star, it must be a planet. So currently, we have evidence for over 300 planets around other stars other than the Sun, but that's only looking at a small fraction of the number of stars in the galaxy. We think that there must be billions of planets in our solar system, based on the number of planets we've found around the number of stars that we've tried to find them around. Right? As we kind of scale up to the whole solar system, there must be billions of planets out there. In fact, we've even gotten a picture of one. So on April 2nd, 2005, right, we actually got a visible picture of the first, what we call extrasolar planet, or sometimes you'll see them called exoplanets. Right? So A here is the star, and B is the planet. Right? It's not making its own light, it's reflecting light off of that star to us. But as you can see, it's a huge Jupiter-sized gas giant. And judging from the picture, you can infer what the temperature must be like on that star, on that planet rather. Right? It's a little toasty. So, but still cool that we can actually see a picture of a planet that far away. So, moving even beyond binary stars, and this will kind of be where we finish off tonight, we can have what are called star clusters. And these are large groups of stars in space, and the key is that they all formed together from the same nebula. So we have a giant nebula that, as gravity pulled it together and clumped, right, these stars formed at roughly the same time, and then similar regions of space. Now, there might still be billions of miles between two of these stars, but they're relatively close to each other. We have two types. We call them open clusters. These are big, loose, disorganized clusters. And then what we call something like this, where it's kind of just a junk show in space. And then a globular cluster is groups of older stars that appear round and packed. So why would a younger cluster like this be open, while a globular cluster like that, an older cluster, be more rounded and packed together? I want you to write out what you think the answer is on your notes, and we're going to check it in class tomorrow. So the question was, why would globular clusters be round while open are loose, are not? Alright, remembering, and the key, I'll give you a hint, is that globular clusters are older, open clusters are younger for the most part. Okay, keep that in mind. Alright, so that brings us to the end of star clusters. You're going to write 3 questions that you have based on the notes. And I will see you in class tomorrow. We'll do a little lab looking at how we detect planets, and then we'll go on to talking about galaxies.